All right. No, 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 no. Don't want to see that. So I had my camera position all set up perfectly, but then I knocked it over just before I came online. I was like, ah, because everything's kind of a little tight in here in my space. But here we are. My gosh, it is a new year. It's 2024. This is the first stream. Don't know if I should really say anything about it. It's been a few years we've been doing this now, and still here, still streaming, still doing Haskell. It's been pretty great so far. This week, I think we're going to continue working on LambdaTrek for the most part. Maybe we'll get around to some nonsense or something, mess around with other things as they come up, whatever. Yeah. I don't know if anybody's into the whole reaction video thing, but been on my mind, maybe doing a couple of those once in a while might be fun. You know, go check out what people are saying about functional programming. See if we can learn a thing or two, you know. Dispel some myths, maybe. Who knows? I don't know. Because I see a lot of interesting takes out there, a lot of interesting ways of talking about it and introducing it. And of course, on this stream, I haven't really done a whole lot of like teaching functional programming or like this is what it is or like what I think it is or how you should learn it or stuff. I just kind of just go ahead and do it. Just to show you that, like, yeah, you can write real software in it, and that's what I do for a living and for fun, you know? Anyway, let's get to it. LambdaTrek is, if you haven't been here before, it's a little game we're building in Haskell. You'll see right here, it's like a text-based roguelike style game or rogue style game where you fly around in a ship kind of inspired by the Star Trek universe, and it's based on an old game, much older game called Super Trek or Star Trek. It had many forms. People have implemented it so many different ways over the years, and this is our take on it. It's called LambdaTrek. And this is what it looks like. Let me fire it up here. And LambdaTrek, bang. Exec. That's the one we want. So this is our game. This is what it looks like. This is like the sector view. So there's like a little bit of local space here. There's a few stars here. And on the right-hand side, we have our little info panel. It shows us a bit about the ship's status. It's the number of torpedoes we have, the number of turns we have to finish the game in. And so the goal of the game is going to be to take out all the enemy ships that have invaded the local quadrant here. And we go sector by sector, fighting them down and taking them down. And that sort of stuff. So the way you move your ship, you give them these commands. This is kind of the very old school element of it. You have like move. And you can move your ship around. You can warp to different sectors. So here's the sector map, or the quadrant map, I should say. And each of these little boxes is like one sector of space. That's kind of just an abstract representation. And yeah, they're all numbered from like 0 to 3 here. So 0, 1, 2, 3. And the idea is you can scan these with your long range scanners. Say like 1, 1. And when you scan 1, 1, it'll tell you if there's what other stuff's in there. So we scanned that one. Not much in it right now that's showing up on our scanners. Maybe that is a thing that should be fixed, because I think that should show up as there. Oh, well, let's see if there's anything in there. So we can warp to it. Warp to 1, 1. So now we're in 1, 1. We can go back to our sector view. Yeah, we see there's a couple of stars here. I think that should show up on the scanners. Or we maybe only show like enemy ships and space stations. That's probably what it is. Anyways, there's a couple of stars there, and our ship is here. Right, so we used a couple of turns to do that, to get there. If you set your warp factor a little higher, you can use fewer turns at the cost of more energy. You have a limited amount of energy, and so on and so forth. So the other little bit of it is you got this cool little dialogue system here that kind of tells you what's going on in the game. Give it a little bit of extra flavor. That's what we're building. I think the last time we left this off, we were kind of working on the procedural generation, so populating space with different things. So the starting sector, we got like 4 stars this time. Probably a little bit much for a sector. But that's the idea. And we go warp to 1-1 here. All right, we got a slightly different layout this time. We got 1 star in here. All right. And we can warp to, let's say 0-1. And we see, whoa, we got lots of stars here. My gosh. It's all made of stars. Cool. So let's dig in. Bring up our code. That's under LambdaTrek here. Bang. This is our little to-do file. Just how I'm keeping organized. We got generate quadrant. We got to generate the player ship. Quadrant generation. All that kind of stuff. Set the initial scan stage. Generate minigame stuff. Blah, blah, blah. Super organized. Let's jump right into the code then. That we were working on. Source LambdaTrek. Boom. Simulation. There we go. And quadrant generate. Alright, so we just have a couple of empty arrays here for the enemy ships and stations and so on and so forth. But we should probably go ahead and build those out as well. It might be cool to have a way for enemy ships to like control the number of enemy ships, so you can control the difficulty a little bit for yourself. That's usually what most versions or incarnations of this game kind of do, and I think that's a good idea, so we're just going to steal that and use it and roll with it. So let's make a variable for that in the game state, maybe, so that we can add that as like an option to set later, and we'll just hard code in a value for now, and that'll be that. Let's see, command, simulation, no, game state, state is what I want. Yes. Of course, whenever I add a value to the game state, I'm pretty sure I'm going to break a bunch of the tests, because I keep doing this to myself and I keep not fixing it. Well, let's get our test runner going. We'll use fast compilation mode, which is just going to byte compile all of our Haskell code, and use the file watcher. Boom. Byte compilation is just a little bit faster because it's not doing any like optimization passes. There we go. Okay, we got some failures already. Awesome. Pattern match fails. Ooh. Recharge. Ooh, okay. We got some broken tests from something. Let's fix those first, shall we? I don't like to leave those broken. I'm sorry I left them broken. Curse you past me. That's okay. We will fix it. Alright, let's start with the first one then. We expected 100, but we got 0 in the doc command test there. Ooh. Okay. Fortunately, hopefully that'll be just a pretty straightforward thing. I wonder what I did, what changed to break that. I don't know. Been a while. I haven't worked on this project in a month. I don't know what I could have changed that would have done that. Yes, yeah. Oh, I think it might have been the initial game state. That's what probably changed. I think we had hard-coded in the initial sector with a space station in it, and now the tests are relying on that fact, which is not a good approach. So the simple fix here, of course, is to add that to our initial sector. Let's hop over to state here. Do. Yeah, so we need to add that back in. Like a fixed sector. Just so that test code can pass again. So let's go into the simulation. I think maybe we still have some of this lying around. Yeah, empty sector is still lying around. This is what we were relying on in our test code here. I don't think anything else is using it, so I'm just going to pull it over. And maybe I'll just put it up here in our test module. And then, if there's a way we can just dump that into our coordinates, our quadrant. So init quadrant, sets our starting coordinate. Let's see, creates a sector star map. Also sets up kind of some hard-coded dummy data. We have this repeated again here. Okay, and init quadrant. I don't think that's called anywhere else. Except in generate. Where we kind of override everything here. It's just... yeah. So we could use that in our test code as well. Because I think we derive all of the... We've got it set up now where we derive all of the sector data from the quadrant data. The quadrant kind of keeps everything in one giant map. And you pull out all the local data for the sector from it. Get sector. Okay. And that basically that allows us to kind of just go over top of quadrant to get like kind of global properties of the game state without having to iterate through a bunch of smaller structures. I guess, kind of, sort of. But kind of the kind of smaller structures here are like all the different maps that we're using for all the different data. Yeah. It's a thing. Any hoozle. Yeah, I think we should be able to use that in the tests. When we init the quadrant data for that test. So if we set the game state quadrant, init quadrant, And the ship's initially at 0, 0, so we'll just pass that as 0, 0. I think that'll make it go. Alright, sector. No longer compiles, because we were exporting that, I think, in a list here. Yeah. Which we removed it, so we have to remove it from here. Skaboosh. Okay. And yeah, so if we're going to move that into the test code, we need some stuff. Or if we don't really use it, we can just get rid of it altogether. Okay, 5 failures, pattern match fails. Okay, we still didn't get our recharge test fixed. Okay, let's see. Oh, where? No, I added that to the wrong one. That's why. That's why. Gotta remember which test you added it to. Don't worry, it's your code. It's happy little code. It doesn't matter if a test breaks every once in a while because you do something silly. Nobody's going to see it when you rebase anyway. Okay. So then we just have pattern match fails in our tests. Probably intentionally. Yeah, I don't really care about that in the test code. It's gotta be what I can disable. Thought I had that disabled with W no incomplete uni patterns. There's another one for GHC, disable, pattern match, fail. That's what I thought that was for. Let's look at the manual. Maybe it changed names or something. I don't think we upgraded GHC in a while. That'd be interesting if we did. Okay. Let's see. No, let's look for pattern. Okay, let's add this one. It's test code. I know that it's supposed to be that. I don't really need the not exhaustive test pattern. Ah, come on. In normal code, this is fine. Like, yes, this is what you want, but gosh, I don't really care about it in test code. I wrote it this way on purpose. I just want to turn that warning off. Which one is throwing this? Uni patterns, okay. Not overlapping patterns. There we go. Maybe this one. Report all unused variables derived from pattern matches, including patterns consisting of a single variable. Not quite, no. It's not unused matches. Maybe you have to do it in one options. Okay. It's not ignoring it there either. How do I get rid of that? Haskell. Disable pattern match fail. Yeah, there's a lot of old ones. Mine's not working. Seems like a newer post. Options underscore GHC. No, that's still not doing it. They're both the same, aren't they? What is this? It's... Okay, well, I mean, that's annoying. There's other ways to fix that, of course. Which is just annoying. I don't know why that's not working. Let's get rid of this. It's one per. Like we had before, because we were using options. Maybe it's going to be options GHC. And if this doesn't work, forget it. We'll just deal with it. Maybe I gotta go for clean. It's interpreted, so it really shouldn't matter. Off to a great start. Okay, super annoying, but what can you do? That clearly doesn't do anything, so we're gonna get rid of those. So we will get the enemy. We will just use from maybe, and possible. Will that work? So we don't have that in scope, because we've dated up maybe. Yeah, we'll do it again here. Well, this kind of works, maybe. Possibly works, thanks to lazy evaluation. It's ugly and gross and kind of annoying, but if it works, then it works. Okay, fix that one. Since we know this will always throw just, we'll never actually evaluate this value here. Kind of ugly because it's going to just be a thunk there, but I'd eventually get garbage collected. And it's only a test run, so. But I wouldn't write this kind of code in production code anyway. So whatever. Sometimes it's just test code and you're not gotta worry about it too much. Let's see if that cleaned them all up. Nope, not quite. Okay. Mistyped one on 310. Used to be applied. There we go. Boom. Impossible. Okay, so there we go. Impossible. Right there. And there, and there, and there. And there. Okay. Ah. It was the runtime checker that was messing us up there. That's what was doing it. It wasn't a problem. So get rid of that hunk. Get rid of that. Yeah, I'll get rid of that one. Yes. Yes. Get rid of that one. Yes. Yes. Oh, no, I didn't want to get rid of that one. Okay, so anywhere we have this pattern of inundating the game state, we are relying on the hard-coded data from that we just removed because we're doing the procedural generation stuff. So we got to add it back in. And that's the fix for all of this. Quadrant. So I'm just gonna pop that. I'm gonna try and make sure at least I match the ship state here. And then kick myself for not creating a smarter constructor that can settle this stuff up. So that we can, you know, do that. And continue to ignore that problem. There's one we set up wonderfully. All right, all right. Got 14, 14 here. Got another one. Boom. That's also 14, 14. Boom. Okay, that's the last one. And there, you got one, you got one. Let's be the Oprah Winfrey here. Game State Quadrant, you got one, everyone's got one. Hopefully. Does the test... Do the tests now say, yes, you all have one. Great. Tests are great. I love it. Okay. Enjoy. Let's commit all that. Yeah. This will be a separate change. Remove empty sector from sector module. And fix tests. Okay, now we can get back to where we were. Oh, so satisfying. Not really. That was fine. Okay. Let's get to the good stuff now. Back to generate. Let's generate some enemy ships. We were going to add it to the game state. That was going to cause us some issues. Just like when I move a little too fast and slip on a key and close my editor. Good for me. Here we go. Okay. Okay, here we go. Bam, bam, bam. And state. What's the other one? Okay. Let's see. Do we want to put it in a structure maybe, or just put a little value in here? Like a config structure, something like that. Game config. Let's try it. We'll put it on here. Num enemies. Number of enemies to seed the quadrant with. That'll need, let's see, an EQ and show instance, of course. And our initial game state setup. And we'll initially just hard code it to, like, I don't know, 10, 15. Okay. 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 All right. By the way, if this is your first time tuning in, chat, welcome. How you doing? You can stop me at any time if you have any questions. Haskell related, game related, otherwise. Happy to take a diversion. Go off on a tangent. That kind of thing. Okay, so we got the game config num of enemies, and that's where that's going to go. Let's go back to the generate code. And now when we go to generate enemy ships, we're going to need that value. When we generate empty enemy array. And so this is going to be kind of a stateful thing, I guess. We're going to have to keep track of as we go along through the generation. how many enemies we have placed so far into the quadrant. So we don't want to place too many. We want to spread them out amongst all of the quadrants. Alright, so I don't know if we should have like maybe a formula for that. Like if I give you 15, let's try and divide them evenly. Or if we should go quadrant by quadrant, have like a roll of the dice. Say between this and so many enemies. So maybe this sector will have 2, maybe this one will have 0, maybe this one will have 5. That kind of thing. And we just keep going over it, iterating over it, until we've placed all the enemies that we can. Until we have no more enemies to place. Yeah. That might be the way to go. Yeah, and then as long as... Yeah, because we'll eventually choose all of them in practice. In theory, the random number generator could always produce like 0 enemies and we'll never place any. But that seems like it would be quite unlikely if we chose a proper distribution. So I think it'll eventually terminate. We won't get like an infinite loop kind of thing. Yeah, okay. So, let's see here. That would be a kind of a stateful sort of looping over top of this mapped elements. Or... No, because if we do it in a single pass, like in this loop here, if we had a function that like maybe split up the amount of enemies somehow and like generated those and we passed it into empty enemy array, like a maybe like generate enemy array. Some kind of like wherever we get n from. That means we'd have to like zip over the list of quadrants and just kind of distribute the numbers using some method. Could we do that? How do we do that? No. Now, I think we'll go into generation state. That has the random gen in it. And let's add some more data to it. We'll add generation. Generation enemies placed. That'll be a number, an integer. And this will be our running total. And now they have that running total. I think there's a function for iterating over that list. Forever. Yeah, we could use this pattern here. So iterate will go and just keep iterating as long as G produces values. And then we could take while on our conditional. As long as we have a stateful iterate, I think that would work. That could work. Which I think we do. Iterate him. From a streaming package. Ooh, that's not what I was hoping for. Of course, we just do it recursively ourselves without having to pull all that stuff in. Okay, so if we're going to do that, what do we got to do? We're going to have an inner function to generate enemy ships for sectors. And we'll map from list over that. So replace this. We'll just call it generate enemies. We're going to need that limit as well. Now that I think about it. Max. Get rid of that. Boom. Ah, come on. Why can't I type that? Oh my god, my fingers are broken. There we go. Bam. Got aligned into my home road, probably. There we go. Okay, cool. Yeah. So then we get that. And then what do we need next? We need... Am I not online? Oh my gosh. What happened here? Twitch is saying I'm not online. But OBS says I am. Okay. Hopefully this is still online. Everything's working. Okay, anyways. Back out to where I was before. So we need to put in the max. Okay. So then we know how many times... Alright, the number of enemies we need to place. And then we have the current number of enemies we have placed. And then generate enemies is going to take some of those parameters as input. So we're actually going to do here. We're going to get to the generation state. We need, maybe we need the gen. No, we don't need the gen. We need just the generation state. We need the max number of enemies. Let's just get the generation state. Okay. Then we are going to get the final number of it. Do we need the final number of enemies placed, or just the final state? No, we have to return this map. That's right. So that means our function could be right here. And it could just modify our generation state as we go. So it could be generate enemies. And we could... we didn't even do that. As long as it's a state action, it should be. Maybe we can do it like this. We just fmap over the generate enemies doohickey. Alright, get rid of that. Generate enemies. You can be a state of generation state. And you're going to return our happy little map. That's going to be the int and the array int enemy. Does that make sense? Well, we're going to put undefined in here just to see if it type checks. It doesn't quite make sense because we couldn't match the types. And these need an F map here. And that's because I was applying this expression to pure, which we actually just want this whole thing to be a function here. We still have one little problem here. We couldn't match the type map int with array int enemy. Expected a list of this tuple to something is, there's still an arrow in the type here, so maybe I need to do it without the F map. Okay, and now what do we get? What's up here? Okay, let's see. Oh, yeah. Okay, so with array and random and stuff, yeah. Not gonna do that. I could do that with record wildcards. I just have to change gen here to generation random gen. And then enemies max and generation enemies placed. I could do it that way. It adds quite a bit. Or get the gen state. And we put gen state such that generation random gen equals gen prime. That's a little better. All else being equal. That was the problem there. What's the problem here? We expected to type standard gen, but we got a function. Thinks gen prime is a function. We get rid of a do by accident. Oh, it's up here. Okay. Or no, that's another one. I might be getting caught by fun stuff. Let's fix this one up here first, as I think it might make the other one go away. So we put gen state such that generation random gen equals gen prime. And this is generation random gen. And okay, now we got them, they're both the same problem. Oh, right. This needs to be gen state. That's a function. And I need a module to use that. It's overloaded record dot. I have a recent enough version of GHC that I'm using here. I should be able to use that. And I do. Gen state. There we go. Of course, this is telling me that I can't. And we go over in the state module there. You have to initialize the generation state. Cool, cool. So we're going to need a standard gen and a game config. We'll just pass it in this way. And then from the game config, I don't need the generation state here. Oh, because I need the gen prime ultimately from it. Let's not worry about that. Okay, you know what? I got the sidetrack there. Game config is something we should pass in as a parameter. Yes. do that in another step. Generation state here. We just pulled it apart, just get the gem prime so we can put it into our game state, and we reuse the same random number generator. So to fix this one, we just need to just get the gen state here and random state. And we're going to hard code the max number of enemies and start it off at 0. Like that. And then we need language overloaded record dot. Okay. Yeah, that's fine. I'll just flip this around. I won't use record dot. I'm kind of mixing record dot with lens here. Just super fun. Oh, the reason why it's not there is because it's not a scope. Oh, generation random gen. That's why it didn't work. Yeah. Okay, cool. Those undefines we know about, so we added those. Okay. Triumph Volcano, welcome. No, I don't want that. Thank you. You're gone. Okay, that's taken care of. Love it when they come in to sell you viewers. Awesome. Okay, so that's basically it. Let's see here. This is generate enemies. It's using our generation state. So we could just jump in here. And start working. We don't need to get state here. So we'll get rid of it. Okay. So when we're doing this, if we're going to do this recursively, we need a base case in order to stop iterating. And our base case will be that when the number of enemies we've accumulated so far, right, the length of this array that we're going to accumulate on is the same length as enemies max. Then we might not even need this value here. Like, we might not need enemies placed. Because we're going to check on every loop if this length is the next, as big as enemy's max. And if the length is as big as enemy max, then we have no more to place. If it's not, then we could take the difference and generate more enemies and put them in a sector and then repeat until we've placed them all. Okay, so our base case will be just that. We will get the gen state out and and then we have to branch, I guess. Unless... Well, the only way we could do... Yeah, no, we have to branch. We have to branch, because we don't have, like, early termination semantics here in the state monad that we're operating in. But when we're recursing, we can't just say, like, okay, return this. Like, if I just put, like, a guard here, like, when this condition's true, do some action. I can't just put, like, pure empty result on our base case and then continue down here on the next line, so I think I gotta branch. So if the... generation enemies max is equal to the length of... so we need our accumulator. So we need that as a parameter. Our accumulator value is going to be the same as our output value here. That's what we'll accumulate on. So if it's the length of enemies, then that's our base case. We've reached it. Pure enemies. Otherwise, we haven't. We have to keep going. We have more work to do. What are we going to do? We are going to... We got to pick some number of enemies to place. And then a sector to put them in. Maybe we want to have our algorithm look at what only sectors that haven't had a chance at having enemies. Or we can just take the list of sectors that have and order them by the number of enemies they have in them. And just take the one with the least. Okay. So first things first, we have to figure out how we're going to get our number of enemies. Num enemies to place. That's going to be using a random generator. or state generation space. State. It's going to be between. Gen random between. We're going to generate, what do we need? 0 and up to the difference of non-enemies so far. Okay. And let's see. Between that, num enemies so far, and the max number of enemies. Oof, that's running over, isn't it? Num enemies so far. Okay. Now we don't have any enemies to place. Now the other thing is, we have arrays. They're fixed size. Alright, so if we decide to place an enemy in a sector, what does that even mean? Alright. Because this sector could be placed again and again and again until we've placed them all. So if we had a really high number of enemies to place. Yeah, we have to be able to... Well, if the arrays are static, we'd have to assign... we'd have to initialize that array of enemies such that it is the max size of that array will be the number of possible enemies you could place, maybe, in the sector. And then you would have to... yeah, then you'd have a function like place 3, and it would be like maybe 3, because you don't know if the sector's full, we can't place that many enemies here. It might not work. So that means the function that we use there to place the enemies in the sector are going to have to... We only have arrays here too, yeah. I'm kind of liking the idea of initializing the arrays with all the possible enemies, at least. I think that's the way we should probably go. I might change this up a little bit, because then we would just flip these enemies at various indices on and off. Basically, if I wanted to place 3 in here, then I know that I have in a fixed array of enemies, I've got 4 left to go. Let me get my pen out and draw this out a little bit. Then I know how many I can place still. Right, because my array will be filled up to a certain point with a certain number of active enemies. Right, so I got my array here, and let's say we can fit, I don't know, 8 is more. But at this step 2, when we're generating enemy ships, we've already generated sector stars. So, like, how many enemies we can actually fit in a given sector depends on the stars that have already been generated at this point in time. 2. Right, so if we've placed 4 stars in the sector, that leaves only so many spots for enemy ships. Maintaining our invariant about sectors as well. Alright. So that's another thing as well. Successive placement of things in the sector reduces the number, reduces the size of these arrays down the road. Right. So, like, once we've placed ships and stars, then there's fewer spaces to place stations. Yeah, that makes sense. Yeah. Okay, so that means this is not quite the algorithm we need. Bam. Game config stuff is fine. Yeah, that's fine. Well, yeah, we'll get rid of that. Boom. Go back to that. That should be good. Okay. So, let's look at sector again. I know we were kind of starting to work on a better API for working with sectors. Enemy ships, station stars, functions, live enemies, build separate tiles. Find empty. List enemies, list stars, list stations. So I think what we need maybe is like a list. The question I need to answer is how many available empty spaces are there? And then when I'm doing my successive generation of these different kind of like layers of adding things, once I've added stars, I can ask, now that I've added stars, how many empty spaces are left? And then I can initialize all of those arrays of enemies to that size. And then when I get to when I get to stations, I can ask the question again, how many empty spaces are there? I can get that number, and that's the number, the maximum number of stations I can place, maintaining all my invariants. Now, this might mean that we oversize the enemies array. That's about it. All right, we'll end up, as we generate the quadrant here, the sector data for the quadrant out on that. Although we're generating this entire map for the whole quadrant. Yeah, we're generating this for the whole quadrant, so all the enemy ships for the whole quadrant. So each int here is a quadrant coord, or is this sector? Yeah, no, that still would be a thing. So, maybe we need a place object here in a sector. Right, we don't have like a generic kind of object type for representing these things. But we do have... So we could write specialized versions of them, I guess. Add enemy... What would that look like? No, it would be the... Because the sectors derive from coordinate, the quadrant stuff, right? Because we work the sector tiles. Yeah. The sector function constructs a valid sector from the sector data we get out from the quadrant. So we really have to look at the quadrant. Or our setter function reaches back from sector space into the quadrant thing here. I don't know. Let's feel this out here with some types. So if we add enemy, we'd have to give it a sector coordinate, an enemy, and quadrant. And this would be like maybe quadrant. All right, that's not too bad. And we know with functions of this shape, we know we could kind of turn this into a stateful kind of function inside of a state monad for our generator to use. And then this would allow us to say, look at the quadrant data for that sector and determine if there's space for adding this enemy. I could do that. I could see that. Yeah. We'd have similarly for add station. I'm gonna do that as undefined. Okay. And if I had this code and it was implemented and worked, my generator then would look a little different. We could even have add star. The stars are just ints. They're just positions. Don't really have any associated data for them. So the way we currently generate sector stars goes through and does kind of the split up sort of mode where we generate the stars for each sector in the quadrant, kind of independently from any other sectors. We just choose arbitrarily between 0 and 5 stars per sector. And then zip them up and return them, and those get turned into the quadrant stars map here, and this list up here. However, those, as we were mentioning, the positions of those stars should take away space in the sector for adding enemies and stations. Okay, so this would be slightly different if we use this function here, add star. So the stars X and the stars Y's, we would still be able to traverse those to generate random positions for them. And then we would basically call something like add star. Well, I would have like a state version of this, stateful version of this, I think, for the generator. Like add star prime or something like this. All right, so we have this sector chord there, the first argument to add star. Something like that. And let's see, we could, and then we need the star's position, so that'd be stars X. Well, we'd only have to generate one. Or we'd iterate over the, we'd iterate over that. Yeah, it would look like, or we throw away the result in zip stars X. Yeah. Like this. Stars Y. Star. And here, we would do add star. And this would be in the sector chord. And we pass in the star right here. The quadrant. So we would need the quadrant in the state here that we're going over. So maybe it would have that like at star prime or something like that. And that would be a stateful sort of thing that would use our add star thing to figure out how to add it. And then this wouldn't have to return anything. It would just be unit. Yeah, yeah. And this wouldn't be this anymore. This would just be... We would need to bind that. Not for the result. Because this would just be unit as well. Although we'd have to get quadrant cohorts in scoop. But I think we have that, yeah. And I think that's pretty much how that code would look. Yeah, yeah. So generation state then would be over our whole quadrant. With our random generator. Quadrant. Yeah, let's just fix those up there like that. Yeah. How that would look. And then our add star function for generation state. Would be what would use our add star helper that we added for the quadrant. Call it add sector star or whatever. Just to differentiate it from add star there. Yeah, and this would be a state, generation state. So it comes to my attention now that I'm using unit, of course, that like add star has maybe quadrant, which the nothing case kind of signifies that we didn't add a star. Might be useful to our algorithm to know that. It could ignore it if it wants to. But if we... something like that, maybe. And then, so this would get the gen state out. Right. And... wait, add sector star needed the coordinates of the sector. It needed the star coordinate within the sector. And I'm doing it with the wrong function. Okay. And what else? That's it. So this would be sector coordinate, star coordinate within the sector. Forget out that. We'd call add star sector coord star core, and the generation quadrant. And then we have something to do with the nothing case, and otherwise we get a new quadrant. And if we do get a new quadrant, then we know that we can put that back into the state. We didn't use the random generator, so we can leave that alone. So we use gen state such that generation quadrant is equal to the new quadrant state. And then I think, so we'll do that. Well, sorry, we've got to do that. We got to put that in there, and then we have to return that we did it. So we'll do pure just sector start board. And in another case, we just return pure nothing. That's roughly how that code would look. So generate quadrant then returns a quadrant. So if we get rid of all this stuff, right, we just call generate quadrant stars. And we can just return the generated the state. Yeah, so this was originally returning a quadrant. Make that unit. We can even wrap this. This might be better with wrapped. Because ultimately what I want to do is run all of these, like generate quadrant stars, generate the next layer, generate the next one, and then just return the finished quadrant when we're done. And then callers of that can just pass in the initial generation state to get started, and we'll do all of the state handling stuff. Alright, so generate quadrant should be like generation state, or even initial quadrant state, or maybe just nothing. Oh, we need the initial state. Yeah, so we'll still need our random generator. Stud gen. That's all you should have to pass in. Yeah. Okay. Done, gen. Get that stud in there. And, let's see. So then we would call this for just the state. And we could put the initial quadrant data here. So we'll need the the argument for that as well. The starting coordinate of the ship. So put that there, ship starting coordinate. And I'm gonna skip this song. Too many lyrics. There we go. Yeah, okay. So then they have to pass in the sector coordinate, the starting ship coordinate. Sorry, the starting ship coordinate and the standard generator to kick us off. Then we're just going to return the quadrant. We're going to do that by setting up the generation state with the rand gen. The quadrant. No, so we're going to need... Because the code that actually calls generate quadrant does need the random generator back after we're done with it. We need to return that as well. And we're done. Okay, so we're going to eval the state, the generation state, the rand gen, the init quadrant, the starting ship coordinate, blah, 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 blah. And we're going to get that final state. And that's a pure function from this perspective. Generate quadrant stars, yes, yes, yes. And the G block, yes, yes, yes. And then finally, generation quadrant and generation random gen. Yes, maybe could just write it this way. Record wildcards, maybe. Random gen, boom. Okay, perfect. That needs record wildcards enabled, so let's go ahead and do that. Language. Record wildcards. Bang, bang, bang. Okay. Oh, because eval state's returning the return. What did I want? Maybe it's exec state is the one where you evaluate it just for the state. Cool. And that's what generate quadrant would look like. Yeah, so what didn't... It turned out it wasn't add star prime we called it. We called it add star to sector. Add sector star. And then we don't have to have this pure line. And we're missing an argument here, which is chord. Okay. Yeah, so this type here is the one I wanted to fix at one point there, so let's fix that. That needs to be a traverse just for the effects. We don't care about that. There's an effectful version of it. Where is it? Traverse M. Traverse underscore. It's updated to foldable. I think I have that. Yeah. Gets rid of that. Okay. So our randgen functions, we gotta fix those. Sweet. Okay, we're running a little low on time. But what I'm really liking about this whole process here is that I'm imagining what the code would look like. I'm putting in a few types, and things are starting to work out. It's a bit of a bigger step than we're used to on the stream. Sometimes, when you don't know what you're doing, just gotta let the types guide you. See what happens. See where it goes. And let it lead you to the design. Okay, so generation state, of course, now has these two arguments. So we'd have to just fix up this definition for get random, as we've done already in the past. So we're going to do that with gen state, as we did before. And then we'll put a gen state such that generation random gen is equal to gen prime. And then gen state generation random gen. And then we need our overloaded labels, which I'm kind of enjoying a little bit as an extension to Haskell. It's like very super lightweight lenses. Of course, we've been using lenses on this project, which I've totally been enjoying quite a lot. But as you notice, like at least with template Haskell generation, depending where you put your splices in the file, you may be able to use them or not, depending on those things. But they're nice, lightweight kind of alternative. When you don't really want to use full lenses on a structure, record, whatever you want to call it. Okay, so we're going to do the same thing here. Call that stud gen, or gen state. Be gen state dot random gen, and we're going to put here gen state such that generation random state will get prime. Yeah, just as before. Yeah. Oh, it's generation random gen, not state. Ah. Yeah. Okay. And this. Okay, get rid of that. Okay, what else do we have left? Here, generate quadrant. What do we say? Generate quadrants to gen. Oh. Mm-hmm. Oh, no. That should be right. Let's see. Oh, that's not pure. There. This is no longer do. That should just be let in. Okay, cuckoo. Let's see. Are we close? Oh, that's over in, yeah, where we're using it. Okay, cool. So we're good in this module so far. Let's go fix that. So here's where we were previously using run state to run generated quadrant. But now we don't need to use run state there. It's quadrant, and our gen state will just be generate quadrant. And we have to pass in the starting position of the ship. Currently hard-coded that. And gen. And then here, we just need gen state. Which we could probably just rename. Yeah, that's good. Okay, and did we compile? Are we back to green? Not quite. Okay, so we're running a little low on time here. Hopefully we can get to green before we end the stream. That would be super sweet. Okay, we're back to undefined calls. That's, I think, kind of expected. We still have those in a couple places. Okay, so yeah, in generate we still have, what is our undefined? Oh, sorry, they're in quadrants. Here. Yeah, because we haven't actually defined add star, for example. So that's getting evaluated. So we can go ahead and implement that. That should be pretty, hopefully pretty straightforward. We get the sector chord. We get the star chord. And with a quadrant. Okay, of the quadrant, we only really care about this map here. Record wildcards enabled here, yeah, so that should be fine. Okay, so now that we have that map, quadra stars in skip. Okay, we need to, this is where we need to actually implement a bunch more stuff. This is where we need to implement our queries over the whole quadrant. Is there an available space to place this star in the quadrant? So that means I don't think we're just that part. We're actually going to need the whole quadrant. All right. Yeah, so we got to ask that question in the imperative. Like it could be, what would be like, is there available space or not? So if we ask the quadrant if there's enough available space, we're asking if there's enough available space to place one thing in it. And that could be like a yes or no question. So we might even be able to put that as a guard function on here. Doesn't need any other information to ask that question. Okay. Just, is there available space to place this thing? And if it is yes, then we can do stuff. In the otherwise case, we would return nothing. And so assuming this function exists, available space takes a quadrant, returns a Boolean. Make it kind of work. Yeah. In the interest of time, we might want to get hacky with this and just I'll just ignore the result. Just make it return true, no matter what you give it. We must have a little to do. Actually implement this. Okay. Okay, so assuming the available space is there, now we can actually change our quadrant. So what we want to do then is update that map at that coordinate. And we have a function for that in map. It's imported as data.map, so that should be m.adjust. I think at key, which would be the start coordinate. And what is it? Yeah, it's usually, oh, okay, it's function first, then key. So start coordinate will be the key. And the map will be quadrants. Quadrant stars. And handy dandy. Overloaded record dot there as well. Bing, bang, bong. Okay, so that's what whatever that function is, that's going to be inside of, yeah, so quadrant stars equal this. And this is going to be, we know we have to return adjust. And this is going to be just quadrant, such that quadrant stars is equal to this new map. This function here in adjust is going to be the value in this map. So it's going to be this list of things. Sorry, not star chord. This is going to be sector chord. This is going to be the well, we get the array. The list here is input. And we're going to put star chord cons down to stars. We'll call it S's. Yeah, I could have done this maybe the point free-ish way. Okay. Here's that star implemented. Boom. Broken it down into smaller pieces. It's how you do. Okay, so now this may still not compile, because we have a lot of other undefines here. Ah, that does. Okay, but we're not gonna, hopefully we're not gonna hit them yet, because I don't think we call add enemy or add station anywhere. So, if we run the game now, cool. We're still good. Are we getting the same stars every time? No, we're getting randomly generated stars still. Yeah, that's good. So let's warp to 1, 1. And that looked good too. We've got a bunch of stars in this sector. Oh my gosh. A bunch of ones in those ones too. In this one too. Cool. So we still maintain random generation now, but we've changed up the algorithm a little bit. I think this structure is going to serve us much better going forward. Right? So we added some game config stuff. We'll get to passing that through still to the generation stuff. But now that we have this new setup for the generation state, we can now query the quadrant. Or potentially, at least. No, we need available states in sector here. So this would have to be quadrant int sector coordinate. And so the idea is that we will be able to kind of ask the quadrant, is there space to place this thing? If there is, go and place it. If not, we can do nothing. And then like our algorithm can, change, if I still have more enemy ships to place because I still got more space in the sector. If I don't have any more space in the sector, we can stop trying to add enemy ships to the sector. We can do things about that. I think this code structure is going to be a little bit nicer. Now we can just kind of mutate the quadrant as we're building it. And so just having that around the quadrant I think will be pretty cool. This code's looking better. So lesson learned there, hopefully. Sometimes you just need to imagine what the types would look like, or would look like if you had the program you needed, and then kind of just plop those types in there, plop a few undefineds in, and just start filling in holes. And just working on the little parts, the sub-problems. And eventually you get a program out of it. Pretty cool. But that's all the time I got for tonight. So we'll see you next week. If this is your first time tuning in, welcome, and thank you for watching. It's been a pleasure. I usually do these streams once a week on Tuesday evenings at about 10 after 8 in the Eastern Standard Time Zone. So if you want to write that down somewhere, you can tune in, or you can just follow here on Twitch if you're watching on Twitch. Subscribe here, whatever it is. Set up your notifications, and then you'll get notified when I go online and do these streams. Because sometimes I do surprise streams every once in a while, and you might want to get notified of those. Maybe I don't. I'll announce them ahead of time. Maybe I won't. You can also go ahead and check out the link above my head here. That goes to the declarative.tv site, where we have a link to a Discord server. On that Discord server, there's a channel for this stream here. You can hang out there, chat about your projects. If you're watching on YouTube, where I archive my streams, you can also maybe chat there. If you're watching in a different time zone or whatever, I don't know what you do with your time. It is not my business, but hopefully it gives you more options. You can also follow me on the Fediverse. I'm on the Mastodons out there at the types.pl server. That's me, Agent Ultra, there. So you can follow me there. I usually announce these streams there as well. This is my website and all that sort of stuff. You can get the links, everything, and all that jazz. What else? Happy New Year. Happy 2024. I hope it's going to be awesome for you. May all your monads be free, and may your types always check. And we'll see you next week. Take care. Peace out.